Hi everyone, so we are moving on to talk about the model of the atom. If you're here to watch the part 3 of this class, where we talked about the terms used in describing atoms, please make sure you do before moving ahead with this class. Now we want to look at the model of the atoms, the discovery of the properties or the subatomic particles that make up the atoms. Now, when you talk about the experiments dated back to the Greek philosophers, John Dalton gave some postulates about the atomic theory. Now, this atomic theory was called Dalton's atomic theory. Now, the Dalton's atomic theory, alongside the modern theory, according to the later discovery by other scientists that proved the John Dalton's atomic theory. So I will be taking the two theories side by side. Talking about the John Dalton's atomic theory, John Dalton states that all matter are made up of small indivisible particles called atom. Now, modern theory made us to know that we have what we call the subatomic particles. So if John Dalton described the atom as indivisible, then where did we get the subatomic particles? And this modern theory proved that the discovery of protons, neutrons, and electrons made us to know that atoms can be divided. Atoms described as indivisible can be divided into those subatomic particles. Now, John Dalton also said that atoms can neither be created nor destroyed, but the discovery of nuclear chemistry told us that atoms can be created and they could be destroyed. You can destroy the nucleus of uranium to form other smaller parts of the atoms. Now, John Dalton also said that atoms of the same elements are exactly alike in every aspect. Is this theory still true today? Now, due to the discovery of isotopes, it was found that atoms of the same elements are not exactly alike in every aspect. Atoms of chlorine-35 and chlorine-37, even though they have the same atomic number, they exhibit the same chemical properties, but due to difference in their masses, one is heavier than the other, so they do not exhibit the same physical properties, even though they are atoms of the same element. Generally, atoms of different elements differ from atoms of the same elements we are describing. That is meant to be true, but atoms of the same elements are not always exactly alike as described by John Dalton. Now, John Dalton also says that when atoms combine, they do so in simple ratio. This theory is only true in the light of inorganic chemistry, but when you get to organic chemistry, most atoms combines in huge amounts of ratios, which they go to higher numbers of atoms when they want to combine. Now, these were the theories given by John Dalton. To be stated clearly, John Dalton stated that atoms can neither be created nor destroyed. All matter are made up of small indivisible particles called atom. Atoms of the same elements are said to be alike in every aspect, and when atoms combine, they do so in simple ratio. Those were the theories given by John Dalton, which were proved wrong due to the discovery of subatomic particles, the nuclear chemistry, the light of isotopes, and the way organic compounds react. Now, when you're talking about the later discovery, the electron that we call the subatomic particles, this electron was discovered by J J Thomson. The electron was then called the cathode rays, not electron. It was later that the cathode rays were called electron. During his experiments, he used what we called a cathode ray tube. This is like the model of the cathode ray tube. Now, the cathode ray tube has a cathode and anode. Now, at high voltage and low pressure, he discovered that some rays were moving from the cathode towards the anode, and when these rays strike the plates, they cause fluorescence. They give a green glow. So the color you get to see is greenish in nature. Now, these cathode rays, he discovered they continue to move along straight line. So those are the properties of cathode rays. So cathode rays, for the fact that they are leaving the cathode, moving towards the anode, they are called cathode rays. Now, these rays are seen to move along a straight line. Now, when these rays move, since they are leaving cathode, they are said to be negative, and they are moving towards the positive pole. So cathode rays are negatively charged. Now, as the cathode ray moves, it brought it into a field. This is without force field. These cathode rays were seen to move along a straight line without the force field. But when brought to a magnetic field, it was discovered that the rays bent towards the magnetic field. So they showed deflection towards the north pole of the magnetic field. A moving charge also creates its own magnetic field. So there is a tendency of the cathode rays acting like a magnet. When we get to physics, you understand what that means. Now, when you put it into an electric field, in this this electric field, the cathode ray is bent towards the positive pole of the electric field. This shows that cathode ray must have been negatively charged for it to move towards the positive pole of the electric field. Not only that, when you take a paddle wheel, if a paddle wheel is placed along the path of cathode rays, due to the kinetic energy possessed by the cathode rays, they can cause the rotation, the movement of this mechanical paddle wheel. As well, when cathode rays are moving along a straight line, they cast the shadow of any opaque object placed along their path. So the shadow will be seen on a screen because cathode rays move along a straight line. So they cast the shadow of an opaque object placed along their path. Now, according to J J Thomson, irrespective of the gas used in the cathode ray tube, the electron is always the same. Electron leaving hydrogen atom is the same as the electron leaving sodium atom. Electron is always the same. So, irrespective of the gas, the charge to mass ratio given by J J Thomson was 1.76 times 10 raised to power 11 coulomb per kilogram. It was later discovered by Robert Milikan. Robert Milikan discovered what we call the charge of electron. The value of the charge of electron, which is 1.6 times 10 raised to power minus 19 coulomb. Now, this charge of electron discovered by Robert Milikan was compared to the charge to mass ratio discovered by J J Thomson in order to know the mass of the electron. Now, let's quickly see that. With the value of the charge to mass ratio compared to the charge of electron, Robert Milikan performed what we call the Hoy drop experiment in order to discover what we call the charge of an electron. The charge of an electron was given as 1.6 times 10 raised to power minus 19 coulomb. Now, the charge to mass ratio given as 1.76 times 10 raised to power 11 coulomb per kilogram. Comparing these two values, we can calculate the mass of electron. So the mass of electron will give 1.6 times 10 raised to power minus 19 coulomb over 1.76 times 10 raised to power 11 coulomb per kilogram. Now, the coulomb can go. Now we have the mass of electron. So the mass of electron is given, as, this will give 0.909 times 10 raised to power minus, when this comes up, it turns to negative, minus 30 kilogram. Now, on approximation, this will be 9.1 times 10 raised to power minus 31 kilogram. You would remember on the table I gave you on the properties of the subatomic particles in part 1 of this class, I talked about the mass of electron to be 9.1 times 10 raised to power minus 31 kilogram. This mass was discovered due to the charge to mass ratio given by J J Thomson and the charge given by Robert Milikan. So Robert Milikan performed the Hoy drop experiments in order to discover the charge of an electron, while J J Thomson performed the cathode ray tube experiment in order to discover what we call the cathode rays, which today we call the electrons. The theories and the properties and the experiments performed by various scientists proved the John Dalton's atomic theory is wrong. And we'll be looking at other scientists like Niels Bohr, we'll look at Ernest Rutherford, we'll look at James Chadwick and their discovery as we move ahead with the class. So please make sure you watch part 3, part 4 of this class before you move ahead to part 5. And at the end of the class, we'll be solving a lot of questions, hundreds of questions on all the things we have been saying so far. So please move along with us from the part 1 and subscribe. Don't forget to subscribe to our channel, like us, and always keep watch till you get more updates on this channel. Thank you.